And then I'm going to talk about what I've seen over the last year as a big data architect and implementer. That talk will include an introduction to NoSQL solutions and some live demonstrations. These will include demonstrations of Hadoop, MongoDB, and some NoSQL solutions offered by Google. So the perspective that I'll start from is the one that I worked with. As you may know from my introduction, I have been an employee at Microsoft. Prior to that, I had my own consultancy, where I was a lead data architect for several large data solutions. This was approximately 5 years ago and before. During that time, I most often created OLAP cubes. This is a special type of data structure that's optimized for reporting. And this was the state of business intelligence when I joined Microsoft as a full-time employee 4 years ago. So this is manifested in different types of database systems. Oracle has a cube-type solution as well. But the idea is that you take your transactional data about, for example, if you are running a store, what you have sold, and then you create a data structure that's optimized for decision support, optimized for reading. Now, there are several different ways to do that. That was the state of business intelligence. The way that I worked with was called OLAP cubes, online analytical processing. The source data, the relational data, was copied, put into a new format, stored again on disk, and then used for very fast read query access. In the US, this is considered old technology now. This technology still exists, and there are still many OLAP cubes out there. But in terms of my world as a data architect, I probably will never build an OLAP cube again, which is a little unfortunate since I've written 3 books about the topic. But technologies do change, they do mature, even in the world of data. And that's really what I'm here to talk to you about today. Since business intelligence really no longer exists in my world, what is the replacement? So for you as students, what should you be studying so that you can be employable when you graduate? So again, I kind of gave you a summary there of what business intelligence was, effective reporting, or OLAP. And in the world of SQL Server, you could either make a copy of the relational store, index it, partition it, replicate it, but you'd have to store it on disk. Now there is a slight bit of improvement in that world. In the SQL Server arena, there is a new structure similar to an OLAP cube called a BI semantic model. And the difference is, rather than storing the copy of the data on disk, it is now put into memory. This is a slight improvement. However, it really doesn't compensate for what has happened in the world of data. So why change? Why do we have to change? Why can't we just use OLAP cubes? Are they not good enough? Why am I standing up here telling you they're not good enough anymore? Because this new trend has occurred. And this trend is that we have tremendously more data available than we have ever had. And when I say tremendously more data, I mean 50 times more, 100 times more, 1,000 times more, 10,000 times more. We have tremendously more data around our daily lives. So because we have this data now available, we need to think differently about how we will store, process, query, and work with this data. And what's driving the motivation to collect and analyze this data is to not only have a structure that allows us to understand the past. Why did I purchase a scarf at a store? Or why did I purchase a necklace? Rather, to understand the potentialities. When I was in the store, what did I do? Where did I walk? Where did I stop? In the US, when we turn on location services for our mobile devices, our mobile providers are selling our actual path when we walk around the store and when we stop here and when we look there. They're selling that information back to the retailers so that the retailers can understand what path the customers are taking through the store, and they can then optimize their presentation. So the idea around big data is collecting not only transactional information, what I purchased, rather also collecting behavioral information, what activities I did in this case. So the retailers can then take that information, and with proper analysis, they can determine what could happen, what are the potentialities, rather than what did happen. So this is just a simple graphical view of, you can see the bottom flat line is the number of purchases maybe someone made, maybe they're doing shopping for the holidays, but the top line shows the amount of behavioral data. Exponentially more. Now I gave the example of shopping. I have another customer that I'm working with, I'm an architect, and they have manufacturing. They manufacture industrial machines, and they manufacture the pieces and they assemble the pieces. So what they've asked me to do is they've asked me to help them to collect more data about their manufacturing process. They've asked me to select the sensors to put on the manufacturing line so that then we can collect data about the manufacturing process, and we can anticipate when the machines need maintenance, when the machines are running suboptimally. And this is an actual job that I'm doing right now. I'm shopping for sensors to add to the manufacturing line so that we can collect exponentially more data. Not just when a part is completed, but the status of that part all the way through the manufacturing process. Exponentially more data. Another example of this is in healthcare. I went to the International Google Conference, Google I/O, in San Francisco this year. And one of the things people were talking about were smart clothing. Clothing with sensors to detect your temperature, to detect your heart rate. So you put a shirt and it has a little thing over your heart. And then all that information about the status of your health can then be analyzed preventatively. So this is being driven through data collection. So from a very academic standpoint, you're probably familiar with this. If you're not, I suggest that you go and study it. This is a representation of classic database data storage theory called the CAP theorem. Consistency, availability, and partition tolerance. And what it says is that database systems can only satisfy 2 of the 3 possible requirements for data. So in other words, a database can be CA, highly consistent, have transactional consistency, and highly available, but it will not be able to be partition tolerant, cannot split it across a broad range. Or a database system can be CP, have high consistency and high tolerance, but the availability might go down because you've got it spread across several nodes. Or you can have AP, eventual consistency, so you'll have inconsistency. Facebook is an example of this, where you'll post something and you'll see it and it'll go away and it'll come back. But it's highly partition tolerant. So this is very relevant when we're thinking about big data, because we suddenly have to deal with exponentially more data. The database systems that we have traditionally worked with are CA, and they fall down at high levels of partition tolerance. So in US, in Europe, what has come onto the scene, and you've probably heard of it here, right? When I was talking to some of the faculty, they were saying they've heard about it, is the implementation of Google's own internal storage technologies. Google created a highly partitionable technology to index the internet. It's called Bigtable. And they wrote a white paper about this implementation, and then a group of people decided to create an open source version of this, and that's called Hadoop. Hadoop is the hottest big data trend in the US. Again, I'm my first time to India, so I'm not as familiar with the Indian market, but I'm assuming it will be here as well. So when people talk about big data, when people talk about NoSQL, oftentimes they believe the only solution is Hadoop. It is one of the solutions, and it is something I would encourage you to start studying and learning, because it has a certain applicability to certain situations. Now, there are many different implementations of Hadoop, and in my talk I'm actually going to show you a couple so you can understand how to get started. It is a database system, if you will. A reason that I started to pay attention to Hadoop, because I didn't last year really pay much attention to open source. I was working at Microsoft, so I was a very corporate, enterprise kind of person, is at the International SQL Server Conference. It was actually 2 years ago now. Microsoft announced a connector from SQL Server to Hadoop. And 1 week later, Oracle announced a connector. And for those of you who are familiar with this, most software corporations do not really want to be connected to anything open source. So it has to be customers that are forcing them to do this. So at that point, I started to pay attention and say, this is an important technology. So as an introduction to Hadoop, Hadoop at its core is actually a type of file system. HDFS is a highly distributed file system. Has a distribution of 3 times by default. 3 times by default, and you can distribute across many, many nodes. Sitting on top of it are additional open source frameworks that allow you to get at the data. Most commonly, you will use HBase. You create an HBase structure on top of the big blob of data, if you will. And an HBase structure allows you to then write queries in a familiar way. You can either write them in Java using MapReduce, or you can write them in Hive, which is HQL. There are other languages as well. So you can work with the open source distribution of Hadoop, and Llewellyn and I we got to tour your facility, and we saw that you have an open source lab. So I would encourage you can look at the open source distribution. In addition to that, Microsoft has a preview, and for the purposes of time, I'm actually going to show you that. So let me show you here. Oh, so hopefully I have an internet connection. If I don't, I'll show you a little video. Let me see if my connection's just timed out. Yeah, just timed out, so it's okay. So this is here we go. This is we'll move it over here. This is Windows Azure HD Insight. So this is Hadoop running on Windows, which is sort of interesting. Microsoft has done a port of an open source product to run it on Windows. Now, I'm not recommending that you necessarily do this, but it's interesting. This is a beta product. You have to request an invite. So it is free during the beta period. It will not be free always, but it's interesting to try out. And what it allows you to do is it allows you to very easily get started with Hadoop. Many of you here are studying programming. And the interesting thing to me about working with Hadoop is not the infrastructure, not setting up the nodes and all that. It's the programming. It's the queries. So here,